What is up, people? Bam! I hope you guys are doing great today. We are going to finally do some graphing, but not like you normally think. We're going to do the graphing you normally think probably tomorrow or the next day. But we are going to graph solution sets today, if I can say it. So we are dealing with something that looks familiar, hopefully, to us. So we have compound inequalities. Oh, no. All bad. I guess we're just going to deal with this for now. So solving compound inequalities. It's like 2 for the price of 1. That's right. So we're going to solve this. Again, your variable is always going to be here in the middle of this compound inequality. We are literally just going to isolate it. Leave it here. That means get rid of the 2. Okay? However, if I'm going to subtract 2, because it's got 2 parts to it, we have to subtract it 2 times. So the first time I subtract 2, I'm going to subtract it over here with this 11. At the same time, I'm also going to subtract 2 from this 7. When I do that, watch this, guys. 7 minus 2, that's 5. Here's my z. The 2 went away because I subtracted it from both sides. And I'm, okay, hold on. Somebody didn't write inequality here. Less than z, less than or equal to 9. Okay? So there we go. I've solved this compound inequality. Bam. Done. Now the tricky part. It says graph it. Okay. Well, here's what you need to know. Less than, all right, less than equals and, okay? Greater equals or, okay? I kind of think the way I remember it is the way I say it. Less than has an and in it. And. Less than. And. Greater. Or. Doesn't matter if it has the less than or equal to or greater or equal to, right? It's still an or. It's still an and. We graph these differently, ands versus ors. So you have to make sure you're looking at this going, okay, this is less than. Right? You read these like a book. Less than or equal to. So this is an and. So I want to graph basically kind of like the intersection of these 2 inequalities. Okay? So here's what these inequalities look like. So I'm going to have a number line here. I'll just say 5 is right here. 9 is right here. Okay? And the first inequality I'm going to graph here, I'll do this in a different color for you, is right here, which says you want z values or numbers that are greater than 5. Where do we find those? Right? So all the numbers that are greater than 5. Because, gang, it's just greater, it's an open dot, right? Versus if we were including it, we would fill in. Okay, so we've seen this before. This should be familiar. Now, the second part, right here, z's less than or equal to 9. Okay? So these are a filled-in dot at 9, and they're less than. They go this way. Okay. Where are these 2 graphs the same? Where are they overlapping? Where do you see 2 lines here? That's what we have to graph. Okay? So right here, this stuff here. Okay? I drew 2 lines, guys, to just help us. Then when I go to actually, okay, give you my graph with my solution set on here. We switch to a different color. Okay, here's what it looks like. So we're a filled-in dot at 9, right? And then we're this solid line, and I'm an open dot over here at 5. Now, sometimes you might like to just draw that below it, right, like that. Perfectly fine. If you want to draw it on the number line, that's okay too, right? So this is your solution set, right? Why is that? Of course I know. Guys, because these are all of the numbers, right, that satisfy both inequalities at the same time, right? That's why it's an and. I want to know what numbers are solutions for this inequality and which numbers are solution for this inequality, okay? And this is how we show it in a compound inequality because we solve the equation. This is how we show it on a graph, okay? So this part not going to be too tough for us today. We will get better okay, at graphing these ones. But again, you got to recognize two things. Is it an and? Is it an or? We haven't seen an or yet, so we don't really know what those look like. Right? Less than means and. Greater means or. And you can't forget about open dots versus closed dots. All right? Okay. Oh, I forgot. This is broke. Hold on. We'll get it working again. Maybe we got to plug it in. There we go. Okay. Awesome, guys. Here we go. Well, I feel like this looks just a lot like the other one that we just did, does it? No, it's different. Okay. Okay, so solve and graph. Again, we're going to solve it. We're going to add 2 to both sides of this inequality, right? When I do that, bam, add 2 here, add 2 here. All I'm left with is x, okay? 5 plus 2 is 7. Negative 3 plus 2 is negative 1. Less than. This is an and. Guys, the chompers, the alligators, always going to be going the same way. You're never going to get one where, like, this would be a greater. That's not going to happen, right? Because they're compound inequalities. Both your alligators, you'll never see this. Chomp, chomp, chomp. They're always going to be going the same way. I can't do it the other way. All right, here we go. I'm going to draw my number line. Again, it's got to go from negative 1 to 7. Your number lines don't literally need to be anything more fancy than like what I'm doing here. Okay? So I'm going to graph this part first. X is greater than negative 1. So where are those? So x values greater than negative 1. All right? That's starting here on negative 1, going that way forever. Okay? Now I'm going to graph this part. X values less than 7. Again, we're an open dot here, going that way forever. Right? I want the overlapping section of these two number lines. Again, this is an and, so this means the intersection of these two parts, right? So where do we see two lines meeting up? Well, all this stuff in through here, okay? So if we're going to graph this, guys, we're an open dot here on 7. We're also an open dot all the way down here. That doesn't look very good. We're an open dot down here on negative 1. Again, every number between negative 1 and 7, right, meets both inequalities at the same time, right? It's true for this half of my compound inequality, and it's also true for this half. That's what our solution set shows us in our graph, okay? All right. Hopefully these are making a little bit more. Oh, boy, this escalated quickly to word problems. A ski resort has several types of hotel rooms and cabins. Okay, so you can pick one or the other. Hotel rooms cost at most, right? Here's your first inequality. Be thinking about what at most means, right? Hotel rooms cost at most $89 a night. Cabins cost at least $109 per night. Write and graph a compound inequality that describes the amount they would pay. Okay. So we have 2 different kinds of rooms, right? So we're going to have like our hotel room here. We're going to have our cabin over here, right? How much it costs will be in the middle, right? And we're comparing. So we're going to have some kind of alligators there. Okay? So $89 a night. Right? This is what, 109. Okay, so hotel rooms cost at most $89 a night, meaning they will never cost any more. It's always going to be less than that amount, right? When we're thinking about our cost here, our cost will always be less than that number, okay? At most. Can we include that? Yeah, we can include 89, okay? So our cost is less than or equal to this. The other part, cabins cost at least 109, meaning they're going to cost at least that much, but probably more. So at least 109. All right. So here you go. Our little alligators were chomping the other way on this one here, guys. So greater. This is an or. We haven't seen one of these yet. I'm glad we had this. Okay, so make your number line. I know it doesn't say to graph it, but we're going to. All right, here's 89. Here's 109, okay? So the first part, I will graph right here, right? Cost less than or equal to $89, right? Remember, filled in dot here because we're including it, right? Less than, all right? Other half looks like this, right? These are our cabin rooms. The cost is greater than or equal to 109. Filled in dot here, going this way. Does everybody see what's going on here? One of our two scenarios always happens, right? When we have an or, right, typically those lines are going in opposite directions. Now sometimes they can be going towards each other, right? And that'll happen on occasion. Well, how do I show this for my answer? Guys, it's an or. So I want to show what numbers meet one condition and then what numbers meet the other condition, okay? And I've done that there in purple, okay? So basically, we just graph everything on ors, right? That's what makes these ones super fun to do, okay? So there you go. So there's that one. Oh, it did say to graph it. We didn't mess anything up. Good work, people. Okay? A professional hockey arena has seats available, right? In the lower bowl, that cost at most $65. Again, at most. The arena also has seats available at the club level. And above that cost at least $80. Okay? So we're not going to spend any more than $65 if we're at the lower bowl. And then we will spend at least $80, right, if we're in the other one. Okay. So again, lower bowl, club level, right, cost of ticket, right? We're comparing all this one. For some of us, it might be easier, I'll just put C for the cost, to do the one that goes from left to right first. So that would be the second one. So the club level and above cost at least $80. So that's greater than or equal to 80. Now you know which way your inequality should be facing for the first one, right? For our lower bowl, right, those tickets cost at most 65. So at most 65. Okay, we're going to graph this one. Guys, it's going to graph literally identical to the one we just graphed a second ago. We're including 65. Here it is, all of those prices that are less than 65. We're including $80 and all of the ticket prices above $80. Okay? Is there ever a situation where we will spend $72 for a ticket? No, absolutely not, right? None of these. That's why this isn't part of our answer, right, when we graph it. Okay? All right. Fantastic. Solve and graph. Beautiful. Okay, look, check this out, guys. This one's an or. And they've just given me the two. Okay, that's fine. So we're going to graph this. We're going to solve this. And then we're going to graph it. Solve and graph as well. Okay? So we're going to add 7 to both sides. 4k less than or equal to whatever 25 plus 7 is. I'm going to believe that would be 32. Okay? Divide by 4k less than or equal to 8. All right, so there's the first part. Second part over here. Move 12 over here, so subtract 12 from both sides. Uh-oh. I wonder, do we need to pay attention to the fact that that's -9? Like if we're just graphing, do we still have to do that weird thing? Mm-hmm. We do. So yeah, if we're going to divide here by -9, that's fine, but you need to flip this. Okay, less than or equal to -2. Okay, so here are your two scenarios. Remember, this is an or, so we're just basically graphing both of these. Okay, so here's -2. Here is 8. All right. Let's grab this one first. All the values of k that are less than or equal to 8. So that would be a filled in dot going that way. Okay? This one says k values less than or equal to -2. That's interesting. So numbers less than or equal to -2. Cool. This one's also going this way. Okay? Now remember, we're just showing both like answer sets, if you will. Here's the first one. Here's the second. Well, are any of these answers not going to be included in this one? No, all of these answers are included. Look, they're all in this portion of it. So when we see like an answer to this one, guys, it literally is just going to look like a filled in dot here at 8. And then that line is just going to go all the way down here. Because this inequality already includes all of these numbers in it. So we don't need to show you that. Like the blue line, that's your answer right there. Okay? All right, so there's that one graphed. Give me something crazy here. Ooh. Maybe we'll get something good here. Again, it's another OR. All right, let's go ahead and solve this. So -2x. We're going to subtract 5 on both sides. Less than that. Again, there's your weird divide by a -2 rule. This will turn into that. Okay? Again, we flip the inequality. 10 divided by -2 is -5. Solve this one. So subtract 15. 5x greater than -5. Okay? X is greater than -1. Remember, we are graphing an OR. So we're graphing both parts just like they are. Okay? So here's -5 on my number line right here. Here is -1. So I want x is greater than -5. So open dot, bam, going that way. Here I want x is greater than -1. Look, same thing kind of happens on this one, doesn't it? Yeah, just kind of going the other way. Again, all of the solutions for this one here, we see already in this one, right? This one just has this. So when I go to actually graph this with my answer, it just looks like an open dot here on 5. And then we go this way. Now, I know what some of you are saying. Well, wait a second. There's an open dot here. We're not going to include that number, right? Well, if we were only showing this answer, you're right, we wouldn't. But is the number -1, which is right here, is it an answer for this one? By this one, I mean this inequality. Yes, it is. So we're going to include it in our answers, right? Again, we're just looking for any of the numbers that meet either of these conditions, right? And all of these numbers do that happen to be bigger than -5. Okay? So guys, I think we should be good there, right? Our quizzes will help get us more practice on graphing these. All right, so if you feel like, hey, that's the part that I'm going to struggle with, or maybe solving these compound ones, like when they were all just written as one, our quizzes will have more help for you guys there. So hopefully that works for you and you get better. If you have questions, let me know. Have a great day.